Good morning. Okay, today we start with the first problem, that is a taps mill. So let me see the first exercise in the taps mill. Okay, so this is the first exercise we need to be execute on the that is a software, that is a taps mill on the taps mill. So this is a rectangular, there is a slab over there, that is a 200 into 150 into 70. Okay, and we need to provide and we need to make the holes, that is a drilling. We need to perform the drilling as well as that is a metric 8 is given, that is nothing but that is a threads. The two threads we need to provide on these two holes. This is the first one and this is the second one. On these, that is a PCD, that is a circle, so we have given there is a 8 holes we need to be provided. 8 holes we need to be drawn on the component, rectangular component, and the required depth and everything will be mentioned in the video. This is your diagram. Okay, so if you want comments you can check complete. This is the first exercise like this. Okay, so this is about the sketch. Now start with the Now let me start in the software. Minimize that. So first what we need to do is go for the VMware. So already installed. This is a virtual machine. Clear. So under that select the Windows XP. So Windows XP, that is will be appear in this. So here you need to select the taps mill, that is a 8.1 is there. I already installed this in the Windows XP. Now we enter into the taps mill 8.1. Okay, here. So these are the steps how we need to be perform to get the object on this software. So this is the instructions you have there. If you want you can go through this. I'll explain all these. Okay. So here. So there is an option called as here the file. First we need to start this exercise, right? So before starting we need to select the new file or a new option, new part. Okay, so in the pull down menu file you can get the new, or directly you can get here also. So this is option file. Okay, new. So here the new, you can select this. So this will be appear. So this is a setup, that is a work setup. So before going to start any part. So units. So units were given in case of different kinds of the units will be there. So our diagram is in millimeter. If it is in the inches, you can select the inches. Okay. This is a millimeter, so I'll select the millimeter. And this is about the workpiece material. So which workpiece material we are selecting, or we are practically performing the operation. It is completely related to the industries, practically what the kind of the material they were machining. So that is important in case of the practical industries when we are using this. Presently now it is using for the lab purpose. Just we need to know about this. Okay, you need to learn this. So why have we mentioned this? Okay, this is about the material to be machine. You need to be select that. So for our purpose, let it be by default we can select the caster and the medium hardness alike. Okay. So this is loading and unloading time. The loading and unloading time is the time between the loading of the next raw material and the previous, that is already machined part. That is in between that time will be there. No? So that is called as it is a loading and unloading time. This is a non-conventional, that is a non-processing time. It's like an idle time. So here it will be we need to be always, it should be minimum, so that we can get the more efficiency in case of manufacture. As it is possible, we need to minimize this. Okay, let it be 60. This is 60 seconds and that is 1 minute. Okay, so in terms of minutes. And the clearance Z. So here we have been considered this clearance Z as 100. So say for distance, let it be 100 only. Okay. So this is the clearance Z is 100. Exposition. So this is a Y and this is everything, it is 100. Let it be. Okay. So this is about the work setup. If you want the same setup, everything when you on the system or when you on the software, you can select the option as save default. Otherwise, So just give OK, and when it comes to our next time, or when you enter into the software next time, again we need to give the same, that is a setup, that is a required for the next part. If you repeatedly using, you can choose this as a saved account. Okay. Here, this is there are three modes will be there. One is the geometry mode, next is the machining mode, and the toolbar. In the geometry, we need to create the part we require as it is, the shape what we require, so that we need to create in the geometry. In the machining, to get that geometry, we need to give the different operations, we need to perform the different operations, so that we need to provide in the machining mode. And in the last, that is a toolbar, here virtually we can see the how the machining operation takes place, that is a tool movement, how it is moving, and how we get the final part, how the final part it will be look after the giving all the operations. So that will be comes under the toolbar. So these are the three important modes. First thing is, we need to, in case of the caps mill, geometry we need to create. What the geometry we require, that we need to be create. So let me go for the geometry. Okay. So here in this case, geometry, we have seen this rectangular slab, right? So having the dimension of it, that we need to be provided, or that we need to be selected. So go for option draw. So under the draw, so there are so many options were there. Okay. So that is a multiple line, arc, circle, radius, chamfer, shapes, point pattern, everything were there. So which one is you require, you need to select that one. So for our object, at the first exercise, I need to select the rectangle. Go for a shapes. Here standard shapes will be available. Rectangle by using the corner, by using the opposite two corners, and polygon is there, slot is there. Okay, so many were there. And the polygon is more than the 4, that is a, if it is like a pentagon, hexagon, heptagon, you can go for the pentagon, polygon. Okay, under the shapes, go for the rectangle. Select the rectangle. The length is given as 200, right? Select the 200, and the breadth is 150, and no radius, there is a no radius, the corner radius, and the no rotation angle. So it is not required for our exercise part. There is a, so that only select 200 and 150. Give OK. Now we got the rectangle. Where we need to be select this, we need to be mount this. So this is a center. Here I will select the center as 0, 0. Okay. Select this. Give done. Okay, it is so occupied the 0, 0 position. So this is a already this is a standard shape. There will be no need to be define the part here, as we going to be defined in case of the caps done, right? Here no need to be define the part in case of the standard shapes. So we don't want to be define that, it is already defined. Okay. So next is go for a draw option. So under the draw option, here the point pattern is there. Point pattern. Among the point pattern, so there are different patterns. Points on line, equally spaced, unequally spaced, parallelogram, grid, circle. Okay. So on an arc with equal spaced, unequal spaced, randomly. Like this, so many options were there in order to. So that is a place a point. So here we are having a option, that is a pattern is there for our exercise. We are having the circular pattern is there. So that select the point pattern. Under that select the points on circle. Yes, right. In the our problem or in our exercise we are having a pattern like this. So what is the diameter of that? PCD it is given. In the problem the PCD is 100. So you need to go with the, that is a problem, that is exercise problem. So there we can get the all these. That is the requirement, what you have to be select on this. And what is the angle of the first hole? So they are not mentioned anything. Okay, let it be 0. And what is the number of holes? In the problem it is mentioned 8 holes. Okay, we need to be we need to be draw 8 holes. And the angle of pitch, they are not mentioned anything. Okay, so just that is the number of holes is, that is here it is 8. Okay, if the angle of the first hole is, if they are not mentioned directly, the hole will be mount on this position. If it is not, if you want at the particular distance, you can give 10 mm, there is a 10. If it is the angle is 10 degree, 20, 30, 40, 45 like that. So from that gap it will start the first hole. Okay, we can see in the next different exercise problems. Okay, this is only thing is 100 mm, that is a 100 PCD, and the next is the number of holes is 8. Okay, give OK. Can you identify this? Yes, the pattern, there is a point pattern. So we obtained. So what is the center of this? Same as it is 0, 0. Select that, give done. Okay, so already it has been placed on the surface, your rectangular box. Okay, so this is about the point pattern. Apart from this, we are having the two more, that is the points here and here one more. Okay, so in order to mount that, go for option draw point pattern. So here having a last option, last but one, point on randomly. So we need to be mount this randomly on this particular area. So we are having here, right, randomly if I select this, it will select. But so in the problem what they have given is, it is how much? This is 33 mm from this side, from the right side, and from the bottom side it is, that is a 36. Okay, here 33, 36 apart from this. So you need to be go to this properly. How it is? It is a, this is 150 mm and this is, the length is 200. Here it is positive 75. Here it is positive, that is a, it is positive 100. This is a negative 100. On the top of this negative, that is a positive 75. Here it is negative 75. Okay. Here we need to be mount this. That is 33 and okay. So from the x direction what it is given. So that is a 33 and 36 it is given. So you need to be subtract that from the, so that is a 100 and that is a 75. You will get the option. So here what is the value is there? 33 is there. From this point 33. So what is the total here? It is given 100. 100 minus 33 is how much? 100 minus 33 is 67. Okay, comma and y. And from this bottom how much it is? From the bottom it is 36. From this point it is 75, right? 75. 75. This is minus bottom side. 75 minus 75 and this is the value is here 36. So that is a 75 minus 36 you will get, that is a, how much you will get? Here 100 is there, right? This is a totally 150 is there. So among this is a 75. 75. So that is, you need to be subtract the 70. Among the 75, 36 you need to subtract. You will get minus 39. Give done. Okay, so this is a point we got here. Okay, so this you need to be go with your, so that is a exercise problem. So you can clearly know about the how to get that value. Similarly one more, so hole is there here. Okay, so that is from this side, from this left hand side 17.5 is there, 17.5. okay, and from this side it is 28.5 is there. Okay, 28.5. so this is 100, right? You know this is a 100 minus 100 plus 17.5, you will get minus 100 plus 17.5, you will get minus 82.5. okay, comma, here it is 28.5, from this side 28.5. so from this point it is negative, right? Negative, that is a minus 75 is there, minus 75. okay, minus 75. so in the minus 75 you need to subtract the 28.5. minus 75 plus 28.5, you will get minus 46.5. 46.5 minus 46.5. okay, so this is a, so coordinate of the second random point. So like this. Okay, so we got the one more hole here. Okay, this is exactly given in the sketch. You need to go through that, then only you can understand. Okay, so this is about the geometry. So this is the geometry we created. So here the hole is required, right? Diameter. So we need to drill. So for the drilling purpose, we not need to be to make the holes here. Just if you give the pattern pointing, it is enough to make a drill a hole. Okay. So this is the geometry part is created. Geometry part is completed. We've done, it completes. This is the only thing we need to be provide on the geometry. So already it is defined. Everything it is defined. Okay. We need to be defined. Everything it is defined, that is a geometry is defined. Why? Because these are the standard shapes, so that by default it will be, so that is a defined. So next is we need to define the blank. The blank is, that is a like a raw material. So we have chosen 0, 0. So that from this side x will be positive, X will be, that is X will be positive, X will be negative, Y will be positive, Y will be negative, so that all the maximum minimum will be comes under this particular part or exercise. So what is the maximum? That is the X is there, X is total, it is 200, positive side is 100. Okay, similarly Y is 150, half of that is 75. Here the X, that is a negative, minimum side is, it is a negative, minus 100, and here it is minus 75. So this is the part we require. If you select the same dimension, we won't get the extra material to, that is in order to remove. So that what we need to do is, just we need to be considered the extra 5 mm, that is instead of 100, 105, instead of 75, this is a 80, instead of minus 100, this is a minus 105 and minus 80. Okay, 5 mm extra on all the sides in order to remove the extra material, in order to get the, so that is a finishing operation on the all the sides, on the sides of the part. Okay, extra, if it is not extra, we cannot remove any material, because exactly we require 200 into 150. Okay, so next is blank. The blank is we require, so what is the blank is we require is, that is a 70. If you select the same 70, what happens? So we cannot make the facing operation, so that extra material we require, let it be 2 mm extra, that is 72. That extra 2 mm will be removed. Okay, so minus Z, this is a Z, Z coordinate is always at the bottom, so that the negative sign will be there. What is the exactly we require? The thickness is 70, so that it is a minus 70. Okay, after this, you understood? So maximum is 100, so minimum is minus 100, maximum is 75, maximum, that is the minimum is minus 75. Extra I have taken 5 mm in order to make the operation, in order to make the side milling operation, in order to get the finished part. Extra, if it is not extra, we cannot remove the material. Similarly, the blank 2 mm extra, so that 72. Here the Z coordinate is always at the same, what the thickness we require, so with the negative sign. Okay, we require a 70 mm, that is a component having the, that is the thickness of that with the negative sign. This is about the blank. Blank is nothing but a raw material. From that we need to get the, so this exercise, that is a part. Okay, so after this we got an extra, that is a rectangle with the yellow color. So this indicates this is a raw material. Okay, from this raw material we need to machine this extra, we need to remove this extra material to get this object. Okay, this is about the geometry completely, creating a geometry, defining a part and defining a blank. Here the part definition is, part defining is not required, only part, that is a blank defined. We have completed the everything, that is a geometry is created, that completed, and the blank is also defined. Next for the, go for the geometry, that is a completion of the geometry. Next is a machining mode. Go for a machining. The first operation is, so under this we need to be make the face, we need to finish the face, or we need to machine the face of this completely, the top face. So here the operation is under the milling, face mill. Go for a face mill, select the new tool. Among the face mill, there are so many options were there. Select the round mill insert. Okay, under that select the 80 mm or 100 mm. So many options were there. If you choose maximum with the minimum, so it should be available in the industry, as well as it requires only minimum, that is the time to remove that. Okay, so medium, that is even though not a small diameter, with the maximum diameter, let me consider a medium sized, that is a tool, that is a 100 mm diameter. You can see here related with the, so that particular tool, 88 is inner diameter, 100 is outer diameter, approach angle is 0, depth of cut is 6. Okay, the body height, it is a length of the, this is a older diameter, and the number of teeth were 6, like this. Okay, you can get the geometry of the tool. So you select this. After selecting, you OK. Select the contour. So this we need to be select outer diameter. Outer, that is a contour. Why? Because this is a raw material. From that we need to get that. After that, it is asking for the process. So what kind of the process? Roughing as well as finishing. We require both, and we can do the this operation, face operation, like this on the, like this surface zigzag, like this, or you can also by the contour, by the from the outer side to the inner side, like this. You can choose any one. Okay, this is the first. I will choose the surface itself. What is the material thickness we need to remove? extra I have taken 2 mm, that we need to be remove this by using the facing operation. Let it be work Z surface 0 only. After the roughing, so here roughing I have selected roughing and finishing. After the roughing I need to provide little material for the finishing operation, so that after roughing let it be 0.5 mm of the material should be present in case of the material, so that 0.5 will be removed by the finishing operation. You can choose 0.2, 0.3 like that. So like this, okay, you can choose anything. A 5 mm, 0.5 mm I will remove. I will remain in the part. After that finishing it will be become 0. Okay. So this is about the face mill. Give OK. And it is asking for from which side it has to be machined. From the, like this, see here. From the right hand side or left hand side, it is asking for like that. Okay. You can choose any one. From the right hand side or left hand side, you can choose any one. From the right side, from the right hand side, if you select right to left, it will machine. If you select the left side, left to right, it will be machine. Okay. So already I have selected that. Okay. So automatically it's selected because of the selecting the another option. So next is machining operation. Select it, face mill, the same tool. Okay. Select the contour, this outer contour. So finishing operation. After this I need 0.5 mm. Give OK. So we need to remove this material of 2 mm. Okay, so this is already this also. Give OK. Now it is selecting, this is, it is giving the machining starting point. Right to left or left to right. You can choose anyone. Okay. So I chosen the right hand side. Right from the right to left it will be moved. Tool will be moved. Okay. This is about the face mill. Next is go for a side mill. Okay, milling operation, side mill. So select the tool. So here it is a different tool. The face mill tool is different. Here it is different. So the side mill is nothing but the end mill operation by using end milling operation. There are different tools will be available with the 2 flutes, 3 flutes, that is a 4 flutes with the finishing and roughing. You can choose anything. So the operator should know that which tool he has to be select. Okay, I will select this. So end mill with, that is a 4 flute. Okay. So maximum flutes, the number of flute increases, so which will increases the machining removal rate. Okay. Minimum, that is a end mill tool with the finishing operation and with the 4 flute. So among that you can get the different 2 mm diameter, 3 mm, see here, 4 mm, 5 mm, 6 mm, 10 mm, 8 mm. There are so many options were there. If you choose minimum, what happens? It requires more time to remove them. So that, so medium sized. So either 20 to 25 range or 20 to 30 range. You can choose any one tool. Okay, select the 30 mm tool, or you can select the 40 mm also. 40 mm, that is a finished tool. So I will select this. Here also go with this. This is about the tool. Okay, flute is 50 mm, that is the length. So diameter is 40 mm. This is the length is whole length with respect, that is a holder face. This is, and 4 flutes were there. That is a 4 teeth. Select this. Select the contour. Again we need to select the outer contour that we need to machine there. From that it will give you get the inner rectangle. So specify the starting point it is asking. Anywhere, somewhere you select this. Machine the whole part. Yes, we need to machine the whole contour. Yes. Here we need to, it is very important, here we need to, you should not select the inner circle. If you select the inner circle, from the inside it will do the milling operation. We need to perform externally, right? So that you need to select the, so that is the external, that is, here it will be look like this, inner circle and outer circle. Inner circle is for inner, that is the side milling. This is outer circle is for the outer side milling. Select this outer side. Okay, after selecting this, again the window appears for the side milling. Roughing is we require. Similarly, side finish we require. Okay. So what is the depth? What is the material width we need to remove is 5 mm. Extra we have considered, no? From, that is 100 to 105. So that we need to remove. What's the depth we need to remove? Completely the whole the depth 70 mm, right? Even you can take more also, there will be no problem, because the complete the the depth of this part is only 70. Even you can take more also, there will be no issue in that, but it should be more than the actually we require. If it is 70 we require, even you can take 72 or 75 like that. So that what happens is the remaining residues which are attaching to the at the bottom, so that will be completely removed if you take the maximum depth of cut. Okay. If you get confused, don't worry, just you take only 70 also. The depth of cut we require is 70 only. Okay. Side allowance. After the roughing, 0.5. Bottom we are not doing. Okay. We are not doing any bottom operation. We don't select this one, allowance. Okay. Give OK. Okay. Side milling is completed. So next is face milling is over, side milling is over, and next is the hole. We need to make a hole, right? So go for a drilling operation. In the hole, first we need to go for the machine. Under the machine, hole, select the drilling option. We have not had any, that is already exist tool, so select the new tool, go for this. There are so many like same drilling operation, center drill, okay, there is a hole, reamer, like that. We need to know that what tool we need to be select. So if it is a drilling, if you choose reamer, it's completely wrong. So then we understood that you don't have any idea about the manufacturing, about the tools and the operations. Okay, so drilling is we can perform by using the insert drill or twist drill. Okay, so that we need to be know that. So with drilling, among the drilling, select the twist drill. Okay, select the hole we need to be finished. In the given exercise, there is a 10 mm hole is there. Okay, select the 10 mm diameter. There is a 10 mm dia twist drill. The 10 mm is there. Select this 10 mm. Okay. That is a 10 mm. 10 mm twist drill. Select OK. Select the point to be machined. So what are the points having a 10 mm diameter that we need to be know before selecting this. So only these 8 holes on a PCD of 100 mm is there now. So these are the only holes with the having the 10 mm diameter. So select these. If you select one, completely it will select all the 8, because this is a pattern, point pattern. Automatically it select all the things. If in case if you don't require any one hole or any 3 hole among this, what you can do is you can select this. Okay, it is asking for select the point to be machined. So I have selected all this. If you don't want any hole, you can select this one like this. If you have select any one, see point pattern don't select, so like this. If it is required, again you can select this. If you deselect this, it will be deselect. Okay, so I require only the hole, that is a 10 mm hole on this. Okay, so this is. Yes, I just cancelled that. Okay, go for this machine, hole, under the hole, drill, select the same thing, already selected, no? So same thing, 10 mm. So select this. If I select the any hole here, okay, any point, it will be select. I require only this pattern, right? I have to be select this one. Okay, give option, done. It is asking, do you want to omit any holes? Among these 8 holes, if you don't want any holes, you can give option as no. No, you give no option and you can deselect that, and that will be not going to be machined. But I require all the 8 machines to be machined, so that yes. Do you want to omit any holes? No, I don't want to omit any holes, so that you select no. So drilling option. So this is the option drill. Let it be work surface. What is the depth we require for this? This is in the problem it is given as hole depth is 25. You can change any parameters if you know any. So that is in case of a practically, the person or the operator will knows the what should be the feed rate, what should be the cutting speed. If you know that, you can change this. Anything it can be changed. The cutting speed is 25 mm or 35 mm, like that you can change. Okay, give up. So drilling is completed, this, and remaining 2 these holes were there, right? So here we need to make a metric 8. What do you mean by metric 8? That is a metric thread. That is an internal thread we need to be provided. Here the metric thread is 8 mm, that is a M8 is there, right? M8 means that is a metric thread 8. If you want to get the metric 8, so what should be the hole? It should be less than the metric size, okay? Thread, it should be minimum than the, that is a maximum thread size. For example, if the pitch is 1.5, let it be, if the point, it is not mentioned in the problem, just I'll explaining you. So here the pitch, that is the pitch size of the thread is 1.5. So what we need to do is, the hole size will be, hole size what happens is, that is the, here the hole size will be, we need to be, it will be less than the pitch, less than the, that is a metric size. Here the 8 mm is the metric thread, the pitch is 1.5. So that what you need to do is 8 minus 1.5. 8 minus 1.5 is 6.5. You need to drill a hole of 6.5 and the remaining 1.5 pitch will be obtained by the thread, that is a metric thread, okay? It's like that. Go for option machine, hole, so that is a drill. So this is not 10 mm, this is apart from that, because of that I have not selected in the first option. Go for a drill, twist drill. So twist drill, so here I told that metric thread 8 we require. 8 means that is the 8 is the maximum, that is a hole, that is a, after the, that is a threading. So here before the threading what we need to do is, less than that we need to be machined. That is, if it is a 1.5 pitch, so that is a 8 minus 1.5 is 6.5, right? You need to select the 6.5 diameter hole, okay? 6.5 diameter hole in order to machine, okay? In order to get the hole, 6.5, select that, okay? Go for, okay? Select the 2, that is a, where we require these 2 is this object. Now exactly you select that particular hole, okay? These 2 require, right? Both the, these 2 holes we require is, that is the 6.5. After the 6.5 we need to make the metric thread, okay? Okay. Do you want to omit any holes? It is asking for, do you want to remove any holes? No. So it is asking. So what is the depth we require? So this is different for the, this is different, this is 20, okay? In the problem this is 20. If you want any cutting parameters to be changed, you can change. I don't want, you select OK. Okay, so this is a drilling is completed, and this is extra, right? For these 2 we need to be make metric thread. Go for machining, enter the hole, okay? So tapping is there, okay? So it comes under the tapping. Select the, understood? One second. Go for machine, hole, under the hole, go for tapping. Select the new tool, what we require. Here already it is given. Different kinds of the taps we can be produced on the part. Fine metric, UNF, UNC, BSW, okay? DSP, NTP, metric thread, okay? That is a tap metric thread forming. This is the first one is metric thread. Here we require, right? What is the metric we require? That is a M8, okay? M8 is there, okay? M8 with into 1.25 is that tap, that is a pitch. But what I have selected is, that is a 1.5 I have selected, as I have assumed that, okay? In such cases what you need to do is, that is a 1.5, 8 minus 1.5 is, that is a 6.75, you can drill, a hole, okay? Select this, metric, that is a metric 8 into this 1.5, that is a tap. Okay, edit the tool. Okay, here the pitch. So what is the pitch? That is 1.25 is there. I have chosen that is a 1.5 because 6.5 I have drilled the hole, so that you can change the pitch. As the thread pitch is 0.5. You can edit like that also. Okay. Give it. So what are the 2 holes? What are the holes we need to be thread is making a thread is this and this point. That is a random 2 points. Okay. Again it is asking, do you want to omit? Do you want to change anything? No, I don't want. I want both the 2 holes to be tapped. That is a tapping. So what is the hole depth we require a tap? That is again 20 mm. Okay, 20 mm we require. So dwell time, don't bother about this. Cutting speed is minimum. Okay, speed rotation. If you require, if you have any specific requirement, then you can change. I don't have any specific requirement. Just I need to know about this. Give OK. Okay. So done. So this is completely, geometry is completed. First is face mill, next is side mill, drilling, drilling for the, so this pattern, point pattern of circular pattern. Next is drilling of these two holes. Why I have selected with a different two option is, this circle is 10 mm and this is 6.5. That is the drill bit size is different, so that two operations I have selected. And the last is, that is a tapping for these two holes. Okay. After this, the last is the tool part. Okay, select the machine. So select here, the machine is FUNOO Plus. You can select the FUNOO machine. Okay. Now you go for the tool path. In the tool path, you need to be select this E mode, this mode. Okay, it is showing different axes, X, Y, Y, Z, ZX, and this is all the three asymmetric view. You can see the all the three. So that is the axis view, and you can see the line diagram as well as this is a line. It is a line machining. You can see solid machining. You can see. Okay, so this is a speed of the. So that is a virtual processing. Just to minimize this, or you can make it. Just go and select this. Start simulation. Simulation speed. This is a simulation speed. You can minimize this, or you can make very fast also. This is very slow. That is a simulation time, because it is maximum. You can see very clearly. Okay, so if you make it a fast, what happens is suddenly all the operations which will be move very fastly. Okay. Firstly, already completed the face mill. Now it is doing side milling operation. Actually, you can see this, like this is called as a simulation. So for this, in case of the caps mill, so what happens is, for the particular operation, automatically the software itself generate the NC program. If you select the small tool, what happens is like this. It requires more, that is the passes, or the more, that is the time to make the, that is a completely, in order to complete that particular process. Just I'll speed up this. Or you can give next to tool. After this, it will be stopped after this tool. Okay, so this is next drilling. It's the small drill bit, that is 6.5, right? This is 6.5. Next is tapping. It is tapping. Yes, this is how it will be the component indicator after the process. Time is tab of 200 into 150 into 70 on the holes of 10 mm, and these two holes with the metric thread. These are the metric. There is a tapping. That tapping process we need to perform in these two operations. This is how we need to be get the, in the tool path we can get the simulation of the part what we have completed in geometry and machining. And here we have a documentation. So here the NC program automatically it will generate for this. Okay. And documentation, among the documentation we can see this power diagram. So what is the power consumed for the different operation, and this is for the first operation. What is that? Face milling, and this is for the, it is showing here, see, face mill, that is 1.359 kilowatts of power consumed. This is side milling, 2.568 kilowatts it has been consumed. And the next is drilling of 10 mm dia, and this is drilling of 6.5 mm dia. And the last is tapping. Okay, you can get the power graph consumed. That is a power graph, that is what is the power consumed for the particular operation. Okay, you should be know in the industry, if you are working means you should be know all these things. Similarly, in the documentation you can see the time study sheet. This is a time study sheet view. Go for a view. Okay, so this, I will zoom this. See this is a cycle time. Cycle time is completely, it will show the each and everything. So what is the cycle time? What do you mean by this is, Yes. What are the different operations being used? What are different operations? What are the tools we selected? See here, 100 dia, round insert, 40 dia is the end mill, 10 dia, twist drill, 6.5 that is a twist drill. This is the 8 which we have chosen. It is just statically, we can change that, modified this 1.5, but chosen is this one only. Okay. And these are the things which are related with this. What is the cutting speed, feed rate, length of, that is a cut length, cutting time, total time consumed, what is the rapid time, what is the total time of this. Okay. Totally cutting time is 229 minutes. Okay. Like this, if the component is large, so the process, if you select the smaller tools, it will be increases the time. So this is the 232 minutes. Okay, in terms of minutes it is given. Okay, this is how we can get the complete information about the, so what we have been measuring. Okay. Similarly, you can get the tool list also. You can get the tool list, what the tools we used. The previous also will get, this is separately for the tools, what kind of tools we used. See, okay. For different operation, what are the different tools we used? Face milling, side milling, drill, and the tap, what are the different tools we used. Okay, it will show, it is everything, what is the today's date, right? So I think it will be updated here. This is the December 21st, 2020. Okay, what kind of the pictures if you are used, it will show the picture name, programmer name, that is a setup number, so what is the part number, okay, it is a part name, and the what kind of a machine we are using, everything, all the details will be obtained in the documentation. Okay, so this is about the, so documents we need to know in case of a particular operation. Okay, this is how we need to be performing this. Okay, thank you.